Okay, so for numbers 45 through 54, you're going to find the domain of f of x, g of x, and the domain of the composition f of g of x. So for part A, we're finding the domain of this function of f of x, and we know that x has to be greater than or greater than or equal to 7. So we write it like this in interval notation. Okay, for B, all reals, because it's a quadratic, it's a polynomial, so x could be any number on the number line. For C, we need to do the composition first. So replace the x in f of x with g of x. So in the parentheses, I'm going to put in 4x squared. And then we're looking for what makes this 0 in here. Okay, and we want to find the boundary point or points. So let's go ahead and set it equal to 0 and solve. So then add 7 to both sides, divide by 4 on both sides, and then take the square root of both sides. So then x is plus or minus square root of 7 over 2. So we know from, I'll just do the work up here, we could place those on a number line, those two zeros. Oops, why did I put square root of 2? So square root of 7 and so we're going to test numbers in a number in each interval, one here, one here, one here. I'll start with this one here because I like to use 7 whenever possible. 0 whenever possible. So if x were 0 here, then this number here would be negative, right? Because 0 minus 7 is negative 7. So then I know that this interval is no good. Can't use it. Over here on this side, I'll probably use 5, just as just to pick a number. So if x is 5, then we're okay. Same thing with negative 5. If x is negative 5, we're also okay. So my interval is from here to here, here to here. So how you can write it is all x such that x is less than or equal to negative radical 7 over 2, or x is greater than or equal to radical 7 over 2. And so that would be the domain. Okay, so the domain for f of x is all numbers greater than or equal to negative 3. Okay. For b, well, b is the same as writing 1/2 x, so it's a linear function. You could write it either way. It's a linear function, so the domain is all reals. Okay. And for f of g of x, we're going to replace all the x's, or in f of x, which we only have one right here, with this function. Okay, so we have square root of x over 2 plus 3. We're going to add the two terms, and again, we need a common denominator if we need, if we're going to add these. So I'm going to multiply by 1, but I'm going to use 2 over 2 as my 1. Okay, so this becomes square root of x plus 6 over 2. So with this function, I see that x has to be greater than, or equal to negative 6. So it goes from negative 6 to infinity. Okay, so number 47, f of x is a quadratic. It's a squared polynomial, so the domain is all reals. G of x, on the other hand, is a square root function, so that one, I cannot have negatives inside the radical, so my domain would be from 0 to infinity. Okay. For f of g of x, remember I'm going to replace this x right here with this function. So I'll put parentheses, squared plus 1, and inside the parentheses I'm going to put in square root of x. And so when you simplify this, you get x plus 1. Now, if x plus 1 were a standalone function, like if you had like f of x equals x plus 1, you would say the domain is all reals. The difference here, though, is that x plus 1 is a composition of f of x and g of x. Okay, so remember that we came in, because this is my inside function, we came in with this function which had this domain. So these were the only real numbers I came in with. All numbers 0 or greater. So when I finish f of g of x, even though it looks like this, and you would think that the domain is all reals, it's not, because these were the only numbers I had available to me to begin with. So the domain for x plus 1, for the composition f of g of x, which equals x plus 1, is from 0 to infinity. For number 48, let me write this function a different way so that you can understand why the domain is what it is. So remember from integrated 3 or algebra 2, x to the 1/4 can be rewritten as the 4th root of x. Okay, so since the index is even, we know this number has to be positive, non-negative, so it could be 0 or greater. So then the domain would be from 0 to infinity. For g of x, because it's a polynomial degree 4, the domain is all reals. So now for the composition, I'm going to take this function and replace this x with it. Okay, so I'm going to take to the 1/4 like that, and in the parentheses I'm going to write 4x to the 4th. And remember the law of exponents, when it's power to power you multiply, so this becomes x. Okay, so x is a linear function, and remember we came in with the whole number line, and this doesn't have any restrictions, so then the domain would be all reals for this one. So for 49, the domain of f of x would be any number except for 0, because you don't want the denominator to be 0. So it'd be all x such that x cannot be 0. For g of x, again, you don't want the denominator to be 0. -3 would make it 0, so then you say all x such that x cannot be -3. Your braces there. And then for f of g of x, remember we're replacing this x right here with this function. Okay, so this would be 1 over, and then parentheses, 1 over x plus 3. When you simplify this, remember this means 1 times the reciprocal of the denominator. So it's just x plus 3. And just like number 47, if x plus 3 were a standalone function, you would say the domain is all reals. But because it's a composition coming from this function, right, this is my inside function, we came in with every number on the number line except for -3. So that -3 is not available to us. So even though at the end -3 wouldn't be a problem if this were a standalone function, but we didn't have it to begin with. Okay, so the domain would be all x such that x cannot be -3. Okay. Okay, for number 50, the rational function f of x equals 1 over x. We say that x cannot be 0, so all x such that x cannot be 0, because 0 would make that denominator 0. Same thing for g of x. So it's going to be all x such that x cannot be 0. For the composition, we're going to take, it's f of g of x, so g of x is my inside function, so I have 1 over x, but I'm going to put 1 over blank, and so in the blank I'm going to put in the function g of x. So this is the same thing as 2x, because it's 1 divided by 1 over 2x, so it's 1 times 2x over 1, just like I did on number 49. So the domain for this composition, for the same reasons as 47 and 50, the domain would be all x such that x cannot be 0, because we came in without a 0 to begin with. Number 51 is an absolute value function for f of x. The domain is all reals. There's no restriction on that. And for b, it's a linear function, so again, all reals. F of g of x, I'm going to replace this x with this whole function right here. So it's like this, and in the blank I'm going to put in 3 minus x. Simplify that, so it's negative x minus 1. So this has no restriction, so the domain is all reals. For number 52, f of x is 2 over the absolute value of x. So again, we just want to make sure that the denominator is not 0, so all x such that x cannot be 0. For g of x, no restrictions, so it's all reals because it's a linear function. And then we're just going to do f of g of x, which would be 2 over the absolute value of, instead of x, we're going to put in g of x, which is x minus 5. Okay, so what would make this one 0? 5, right? The denominator. 5 would make it 0. So then we say all x such that x cannot be 5. So that would be the domain of this function. Okay, so the domain for f of x would be all reals because it's a linear function. And then for b, anything that would make the denominator 0 has to be excluded from the domain. So we were going to say all x such that x cannot be 2 or negative 2, right? So plus or minus 2. For f of g of x, I'm going to replace this x right here with this whole function right here. So it's going to be blank plus 2. So in the blank, I'm going to put in 1 over x squared minus 4. So to combine the two terms, I'm going to put a 1 underneath and multiply this with the least common denominator, which is x squared minus 4, both in the numerator and denominator, because this fraction has to equal 1. Okay, this one always has to equal 1. So distribute the 2. And then we have 2x squared minus 7. Okay, so with this problem, with this composition, I know my denominator is the same as in part B, right, as g of x. So I know that it's going to be all x such that x cannot be plus or minus 2. And the numerator doesn't really change the domain because there's no square root or any even indexed root in the numerator. So the numerator, like I said, doesn't change the domain in this problem. So the domain is the one right here. X cannot be plus or minus 2. For number 54, we're looking for any value of x that would make the denominator 0 and exclude it from the domain. So we know that x cannot be plus or minus 1. So all x such that x cannot be plus or minus 1. For b, g of x is a linear function, so the domain is all reals. And for f of g of x, let me just write that down. So we're going to take this function and replace it here and place it in, put it in place of that x right there. So it's 3 over squared minus 1. In the blank, in the parentheses, we're going to put x plus 1. And remember when you square a binomial, do not forget that you